Thank you for watching Knowledge Academy.
Okay, in this video, we are talking about parametric surfaces in vector calculus. So first thing first, what is a parametric surfaces? Just like we have a line and we take the line and this curve, or maybe we have a straight line. I take this straight line and then the equation of this straight line x equals to y, or y equals to x, or x plus y equals to 1. We have equation. So we need x variable and y variable in order to define this equation. We have a better way. We can write x equals to x naught plus at, y equals to y naught plus bt. And if you have a 3D, it's going to be z equals to z naught plus ct. These are the parametric form of this equation. What's the advantage for parametric equation is I only need here, when I solve this equation, I know x naught, I know y naught, which is our the component for coordinate for this, and this is my x and y. Okay, so the advantage of that, when you solve this equation, is going to be come out in the form of t. So if you know t, if t is known, you can find both x and y regardless of any point. And we set the limit of t equals to, go from 0 to 1. It means if you are here, t equals to 0. If you are here, t equals to 1. And in between, you can pick any point you want. Whatever value from t, it should be going to 0 0.1, 0 0.2, 0 0.3. And you can find both an x and y in that coordinate. Same thing, we do have a surface. And parametric surfaces means if I have a surface, I can find the area of this surface equals to x and then y. If I'm asking you the area equals to x times y, and that give it to you basically give it to you x times y, the area. Okay, I wanna do the same kind of setup, but I have another problem. If I have a shape like this, right, how can I find the area of this kind of curved surfaces? So what I do, I usually do one thing, is just to split into pieces. And every piece, like this piece, is going to be look like a little surface, and every piece look like a little surface. If I need more accuracy, right, definitely is not accurate as the other surface, because every surface is going to be look like a little bit curved, and my patch is going to be look like a little bit straight. So I have a little bit error in this, or I can say a little bit compromises. So if you have a curve like this from the side, like this yellow curve look like this, if I split into parameters, it's going to be look like lines, right? So these lines are definitely going to go this way, and then you can make these little patches, which is I just mentioned here, number 1, number 2, number 3. For those patches are not exactly similar to that. If you want more accuracy, you can split into further, you can split into further, you can split into further, you can also split into this way. Okay, and that is the whole concept of parametric surfaces, where you can split your area into small pieces and came out with this. Now if I take little piece, this piece, I can call them on d and n axis, or I can call n and v axis. So I can call v and maybe n, two axis, vertical and horizontal axis, right? So my vertical axis is this one, my horizontal axis is this one, and this keeps shifting. And there's a big patch is given. Out of this patch, I can take this, out of this patch I can take a small differential area, right? I can pick it here, this guy, and that I can call this is delta H, and then I can call this guy is, this side is delta V. Okay, if I want to calculate the area of this little patch, I can also draw into 3D view. So I have a little patch like this green color, and then I can take a small little differential area. This is a delta v, sorry, h, and then this is delta v, right? Just vice versa. And if I want to get the area of this one, I can write the area of this delta A, this area small patch is delta U or delta H or delta V, right? I can call delta H delta V. Now the point is that what is the position of that one? In order to get the position, I need two position vector, and the position vector should be the side of this and side of that. And I can call it RA and RB. So here I just have to multiply these two with RA and RB. And I'm going to call RA cross RB. We learned long time ago, if you have two vectors RA cross RB, and if you take the cross product for RA is this, RB is this, the cross product is going to be 90 degree to both, like 90 degree here, 90 degree here. So bottom line is that this little area is going to be perpendicular to this little patch. Okay, and I can just write the area of a parallelogram. If I have like this kind of shape, I can write the area of the parallelogram equals to RH times RV and delta, V delta H. That's my area. But in the differential form, like little this thing, if I have a differential form, I can also write this area, surface area of this little patch. I can write like this. And I can put the limit, because remember, I have only area for this yellow little patch. I need the area for this whole thing. From here to there, I need the area, and here to there, I need the dimension. So maybe I can call it B and A. So AB, and here I can call CD. So if I want to write the parallelogram area, I can write this function inside the as a function driver for this integral. So RH, RB, and then delta V, delta H, and then the two limit is AB, CD. And this integral actually gave me the area for this whole thing. And that's the whole concept of parametric equation. Okay. So now let's talk about how can we prove the area of a sphere. The area of a sphere is 4 pi times r squared. Okay, so let's take a look. We're gonna do the same concept, parametric equation. Surface area of a sphere. Usually we know the formula 4 pi r squared. And the question is how? How is going to be possible? So what I'm going to do, I'm going to take a surface, any sphere, a 3D sphere, and this sphere have a bunch of, it's a 3D, so I'm just going to be writing these, making these lines, so you get feeling it's a 3D surface. And the formula of this, the area, the sphere, the equation is x squared plus y squared plus z squared equals to a squared, right? This a is the area, sorry, the radius. Okay, now what I'm going to do, I'm going to take this, and I can also know this in spherical coordinate. If this guy is a, it has 3 component, right? I can write 3 component, this component, this component, this component. This component is AR cos phi, and phi is my angle with z, and theta is my angle with x-axis. Okay, So what I'm going to be doing, I'm going to be writing this, and that my angle, and that is theta. So I can just substitute all these value. I'm going to call this is A. So this is A cos phi. This is A sine phi cos theta. This one is A sine phi sine theta. Okay. I'm going to go back and writing the equation R phi time theta equals to, and I'm going to be writing my equation ijk form. So it's going to be xi yj and ck. Since we have all these components, this is my x component, this is my y component, I can just substitute the values here. So I'm going to substitute the values, going to be look like A sine phi cos theta, that is my x, right? This is my x-axis, and this is my y-axis, this is my z-axis. So that is my x literally, this is my y, and this is my z. I'm going to substitute values here, and it should be an I, then plus A sine phi sine theta j plus A cos phi k. The two limits are given, theta and phi. Theta is going from somewhere to somewhere, phi is going from somewhere to somewhere, and I'm going to writing these two limits. This is going to be going from 0 to pi. It's going to be going from 0 to 2 pi. Okay, and what are we going to do now? We're going to be we're going to be writing this equation, and we say take the derivative with respect to phi. So I need r phi and r theta. All I do, I just take the derivative with respect to 2, so I can substitute into my, so I can calculate this. Not A, I need to calculate. So I'm going to calculate r phi times r theta. I need a cross product of the two, so I can write here, but I need to take the derivative. The derivative will be A cos phi. If I take the derivative of this equation, it's going to be A cos phi cos theta plus A cos phi sine theta minus A sine phi k, and then I have substitute the I j k. Right. For r theta, I'm going to be writing minus A sine phi sine theta plus A sine phi cos theta j I and plus 0k. And here I'm going to be substituting into, take the cross product of the two vector, number 1 equation, number 2 equation. I'm going to take the cross product. It's going to be A cos phi cos theta, A cos phi sine theta, and then minus A sine phi. The lower one, which when we are theta equation, A sine phi, sine theta, then A sine phi cos theta, and then 0. If I take that cross product, is going to be, I'm going to take the I, so multiply this to this minus this to this. When I take the j, I'm going to multiply this to this minus this to that, and when I multiply k, I'm going to ignore these two and multiply this to this minus this to that. Okay, just going to remind, we already know about that one. So I'm going to writing my r phi cross r theta equals to A square. I'm going to just do the direct multiplication. a square sine square phi sine theta plus a square sine phi and then cos phi. Okay, I need a magnitude of this. I need a magnitude of that. So what I'm going to do, I'm going to just writing a magnitude is going to be r phi times r theta magnitude, and magnitude is equals to x square plus y square plus z square. So it's going to be a square, and then a square is going to be a4 then sine 4 phi then cos square theta plus a4 sine square sine 4 phi sine square theta plus a4 sine square theta phi, and so it's going to be cos. When I take the I take the common and then substitute the values, a x squared sine squared theta plus cos squared theta equals to 1. It's going to be simplified sum of them, so it's going to be a4 now again take the common, is going to be a square sine phi. Okay, I'm going to take this value for r phi times r theta and taking my integral and substitute into my integral, and integral is a equals to this r phi time r theta d phi d theta. Okay, the two values 0 to pi and 0 to 2 pi, 0 to pi for theta and for phi, and then 0 to 2 pi for theta. Let's go to the next page and solve this equation. It's fairly simple. Maybe we can solve it here if you could. Yeah. So I'm going to take the derivative of this one, is going to be look like this. Area of a sphere equal to 1 to 0 to pi 0 to 2 pi, and this whole thing I solve it is equals to a square sine phi d phi d theta. If I take the integral for the first one, it's going to be a square 0 to pi 2 pi, and then if I take the integral, it's going to be minus cos phi d theta, and the values or limits are pi and 0. When you substitute the value, is going to be a square 0 to 2 pi, and if I take this one, it's going to be cos pi minus 0, so it's going to be just left over nothing but just 2. 1 plus 1 plus 1 is going to be 2 d theta. If I take another integral, it's going to be a square, right? A is my radius, by the way. A square 2 times 2 is a 4, so it's going to be 4 pi a square, and that is what we prove here. Another problem. In this problem, find surface area z equals to minus x, and inside of x squared plus y squared equals to 4. What exactly is the shape is, I have like a this kind of cylindrical tube, x squared plus y squared, and I have a plane z equals to x, so maybe I can go to, this is my z equals to 0 and z equals to minus x, so I'm going to go down, and here I can make a surface. If I make a surface like this, really this surface is going to cut this cylinder and then this area inside, right? And what I want in this problem, I want to calculate that area, right? How much is the area? So what I'm going to do, the first thing first, I'm going to start solving this. I'm going to be writing my equation for r comma theta. Two things, r comma theta, this is what we got. So it's going to be r cos theta. So x, y, z, right? X, y, z component. So I'm going to be writing here r cos theta, r sine theta, comma, z equals to minus x. So we're going to say minus, and ix equals to minus cos theta. So minus cos theta. Here r is going from 0 to 2, theta is going from 0 to 2 pi. These are the two limit of two variables. Sometimes I have a u variable, v variable, hv variable, xy variable. Now this equation, because it's a cylindrical coordinate, so I have r and theta. What I'm going to do, I'm going to be writing my surface area equation. Surface area equals to integral in a parametric form 0 to 2, 0 to 2 pi. So it's going to be dr for 0 to 2 and then d theta for 0 to 2 pi. And here I need a cross product of the two position vector, which is my position vector is rr cross r theta. Okay, so before moving forward, I need to call this equation 1 and finding out r cross r theta. And this one is equals to, I'm going to just substitute the value I, j, k. I can directly take it, so I need to take rr, and rr equals to r. If I take this for this equation, I'm taking partial derivative with respect to r, so it's going to be cos theta, sine theta, and minus cos theta. When I take the partial derivative with respect to theta for this r theta, is going to be look like this: minus r sine theta, r cos theta, and r sine theta. Okay, and I'm going to just solve this thing, and it's going to be look like I multiply this sine square and sine square, so it's going to be sine square theta plus cos square theta, and then r times 1, just r is left over. This whole thing becomes 1. Okay, and I'm going to do minus j. Here if I do this thing sine, so it's going to be r sine theta cos theta minus r sine theta cos theta. So this guy cancelling out this guy becomes done, and then plus I'm going to write here, so we have enough space. K is sine cos square theta plus sine square theta, cos square theta plus sine square theta, and then r. If I simplify it, this becomes 1, this becomes 1, and this is gone, so it's going to be look like r times r theta. 0 plus k r. I technically need the derivative. I need the magnitude of this, right? I need the magnitude of this. Substitute here. So I need to do r times r theta, and I need the magnitude. The magnitude is going to be r squared plus 0 squared plus r squared, so it's going to be 2r squared, so it's going to be square root of 2 and r squared. Okay. And then what I'm going to do, I'm going to be just taking this and substitute into my integral. So surface area, or I can call SA means surface area 1, 2 from equation 1. I'm just writing this equation over here. Is going to be 2r square and drt theta 0 to 2 and 0 to 4 pi. 2 pi, 4 pi, 2 pi. This is only a circular shape. So I'm going to take something out this and then take the derivative. So it's going to be 0 to 2 pi, then r squared over 2, 0 to 2 and d theta. If I substitute the value, is going to be square root of 2 dot 4 and pi, right? And that is pretty much my answer. I can maybe take this 4 outside, 4 to pi. That is my answer. Let's look at another problem. X squared plus y squared equals to 4 between z equals to 0 and z equals to something, some equation. Z equals to 0 and z equals to some equation 16 minus 2x. Okay, this is two limits are given, and look like x plus y squared is called r. So I have, maybe I can just draw this. So look like this is a cylindrical shape like this, and this bottom line is where the z equals to 0 and z equals to, for 16 minus 2x, look like it's going to be cutting frame, cutting plane, and this is a z equals to 16 minus 2x, and if I cut this plane, it's going to be look like this shape. This is a plane, right? So this is going to be plane is cutting this shape. So I need the area of this. So I really, what I want, just find the surface area between this and that. So really what I want the surface area between this line and between this line. So really it's going to be look like this shape, this shape, this shape. So I need the surface area for this, and on the back side, like how it's going to be wrap around is this, the complete surface area of this. Already, so we have x, y, z, x, y. X is going to be maybe this way, y is going to be inside this, and then this guy is z. So first thing first, I'm going to be writing the equation of my, so I can start my parametric equation. So I have a theta and z, and my z is my height, and I'm going to be writing r x equals to r cos theta and y equals to r sine theta, and then z is z. Then I'm going to call r theta and then r z, my two variable. So I'm going to be writing minus 2 sine theta 2 cos theta plus, oh, not plus, but the z derivative is going to be 0 because there is no variable for theta. Rz equals to 0, 0, 1. Right? If I take the derivative 0, 0, and then z, partial derivative with respect to z is 1. I need to find this cross product between the two vectors. And then we minus 2 sine theta 2 cos theta 0, then 0, 0, 1. And go I2 cos theta plus J2 sine theta plus 0 k. R theta, Rz, I need the magnitude, and magnitude is equals to really 2 square cos square theta plus 2 square sine square theta. I'm going to take the 2 common, so 2 comes out just like 2, and then this becomes equals to 1, right? So my answer is 1. Cos square theta plus sine square theta is 1. I'm going to take the 2 square common, so only 2 square left, and 2 square cancelling out the square root, the answer will be 2. Okay, now substitute the value. It's going to be surface area, S is a shortcut of surface area, equals to integral 0, 0, both starting with 0, and I'm going to be writing here d z t theta. These is to start from 0 and then cutting on this plane, like this plane. So really my top is equal to 16 minus 4, sorry, 16 minus 2x. So I can also write 16 minus 2x, so 2x equals to 2 cos theta, so it's going to be 4 cos theta. So I can rid of this 2x in writing 4 cos theta, right? Because I need the value in the theta form, and the d theta is going from 0 to 2 pi, because it's a complete round. If you see from the top, it's going to be go from make a complete run, so it's going to be 2 pi, 0 to 2 pi. Okay, and then here I want to be writing my equation, and that equation is this, sorry, is r, and then z. I can rid of this and just substitute the value of 2 because this is what we got to. Fairly simple now to solve. Surface area equals to 0 to 2 pi, and here is 2. dz means this minus 0, so 16 minus 4 cos theta minus 0 d theta. If I take the integral again one more time with d theta, is going to be 2 times 32 minus 8 cos theta and d theta, 0 to 2 pi. So it's going to be 32 and theta. I'm going to be just doing this, yeah, 32 theta 0 to 2 pi minus 8. When you take the integral, is going to be sine theta, and it's going to be 2 pi to 0. When you substitute 2 pi, this becomes completely 0, so it's gone. The only thing is left over this is going to be 32 2 pi minus 0, and the answer is 64
Thank you for watching Knowledge Academy. Please subscribe my channel.